Hello, this is Michael Swanwick from Creare in Hanover, New Hampshire. This presentation is optically transparent, spray-coated windshield heater. This is with collaboration of our nanomaterial partner, NanoC. Creare is a technology and product development company that's been around for over 60 years. We are independently held by a partnership of engineers. We have a wide range of clients from industrial to the government. We have successfully transitioned and commercialized technology through a very varying ways, including licensing, making our own products, and spin-off companies. We have a very deep technical base here with over 70 engineers, many of which have advanced degrees. From our broad capability, we have what we like to say from the Martian surface to the factory floor. We have turbomolecular pumps that are currently on Mars, and we are developing nanomaterials for a transparent heater in this project. So a very wide range. We can go all the way from proof of concept to prototypes to product, and we have successfully shown this transition time and time again. And we are currently working with our sister company named Idari to do low-scale manufacturing. So Creare is developing a carbon nanotube-based windshield heater. This is for the Navy to have a robust heater for their tilt rotorcraft that is capable of repeatedly large strain that the current indium tin oxide or ITO coated windshield often fails in. This is part of the V-22 fleet to increase the readiness while decreasing maintenance cost. This will need to be powered by the standard aircraft power supply of 3-phase, 200 volt, 400 hertz, the power density of up to 5 watts per square inch, with holding a 10-degree variation across the full windshield, with less than 10% loss in the visible and near visible spectrums, with low haze of less than 3%. It also needs to have EMI shielding of 30 dB with high cycle loading of up to 2% strain for 500 cycles. These broken ITO windshield heaters in the aircraft can lead to very long downtime and significantly increase the cost per flight hour. Our nanotube-based windshield heater is highly resistant to repeated strain and a very robust technology for both the V-22 tilt rotorcraft and rotorcraft in general. Really, any windshield that is plastic-based will benefit from this technology. Our technology is also a drop-in replacement with very high optical quality and heater performance. And it was improved robust windshield heater layer for greater flight readiness and decreased operating costs. Our Massless Spray system includes a 6-axis industrial robot spray head system enclosure to deposit carbon nanotube hybrid-based material on transparent windshields. This technology is done in atmospheric conditions as opposed to the ITO-based heaters that have to be done in large vacuum deposition systems that are extremely expensive. We've worked with NanoC, our ink development partner, on developing a one-pot CNT hybrid ink that is shelf-stable, sprays highly uniform coatings with very low sheet resistance, extremely good optical quality, low haze, all the way from the visible to the near visible for night vision capability. So where does the technology stand now? We have developed flat and curved 10-inch square coupons with over 90% optical transmission in the visible and night vision spectra from 450 nanometers all the way out well past 900 nanometers with low haze and low sheet resistance. We have fully developed, tested, and assembled our massless spray system that includes an industrial-based 6-axis robot, full enclosure, ability to spray a full-size windshield. We have also developed algorithms and tool paths to coat any 3D shape as long as the radius of curvature fits in with the robot. So it will easily be able to do any type of windshield, whether it's a tilt rotorcraft or a rotorcraft or potentially automotive or lots of different shapes. We have tested these 10-inch square and curved coupons, and we are currently waiting for the phase 2 option to get turned on to demonstrate a full-size windshield and laminate structures, and we expect that to be in 2022 and 2023. Because our massless spray system is deposited in normal atmospheric conditions and not under vacuum, we have the advantage of being able to rapidly set up in between parts, which greatly reduces production costs. In working with our nanomaterials partner, we developed a one-pot CNT hybrid ink that is shelf stable for long amounts of time in ambient conditions, which greatly minimizes capital investment costs. We made our system highly automated with an industrial 6-axis robot, which allows for high degrees of freedom. And also we put in systems for quality assurance, including standoff monitoring, temperature monitoring, and we also have QA controls for sheet resistance and optical transparency. These all should meet aerospace specifications. We've tested our heaters under repeatedly high strain at over 500 cycles, and they've easily outperformed the laminate structures that are previously on the V22. Our film quality is highly uniform. The heater is very uniform. It has low haze and high transparency, and it should meet all the flight requirements. As part of this, at the end of our phase 2 option, we plan on offering the Navy a full-size prototype windshield for them to independently test. We are currently on our projected development timeline. We have finished our SBIR phase 2 base, and we are expecting the phase 2 options to start shortly. They will include laminate structures and a full-size prototype. From there, in a phase 3, we will scale up to a windshield prototype that will be integrated into an airframe and built units for static ground testing and dynamic flight testing. From there, we expect to continue to other rotorcrafts and hopefully pilot production of tilt rotorcrafts in the future. We expect the market for this carbon nanotube-based transparent heater to be quite large, with direct sales of the V22 during the sustainment period, along with other tilt rotorcraft and rotorcraft in the DoD, especially with the Arctic strategy. There's going to be a need for robust, transparent heaters in the near future. As far as commercial applications, there's fixed-wing aircraft and rotorcraft there too. And then ironically, as many automotives have moved to LED lighting, there's a need to de-ice and defog both windshields, but also lighting and sensors and LiDAR imagers. And then there's also the recreation department, including snow sports, performance eyewear, headgear, etc. So at the end of the phase 2 options, we have developed a full-size prototype for the Navy to evaluate. From there, we will fabricate and fly pilot production units, working with our sister company Udari that specializes in pilot manufacturing of advanced technologies. From there, we will complete the pilot manufacturing under a phase 3, working with a current windshield manufacturer. Then we will transfer this technology and the pilot manufacturing techniques to a current V22 windshield manufacturer. From there, we'll develop other commercial applications, including fixed wing, automotive, optically transparent covers, including lidar, sensors, lighting, imagers, etc. Thank you for listening. Again, this is Michael Swanwick from Creare. Paul Mavizzo is a former Navy pilot and our DoD Business Development Manager. We are located in Hanover, New Hampshire. Come see our prototype transparent heaters. They're highly robust, spray-coated under atmospheric conditions. We are able to coat 3D shapes with complex curves. We are able to make gradients heaters with optically transparent gradients and heat gradients. And we have a highly flexible manufacturing process. Thank you for listening. Goodbye.